The James Webb Space Telescope has stunned the scientific community yet again. After only a short time in operation, it has already rewritten much of what we thought we knew about the early universe. But now it has gone a step further, detecting an enormous cosmic structure that dates back to nearly the beginning of time itself. This newly discovered formation is estimated to be 13.8 billion years old, nearly as old as the universe itself. And what makes it even more shocking is the sheer scale of this ancient object, and what it might tell us about how the cosmos evolved. To understand the significance of this discovery, we have to first go back to the early moments of the universe. Scientists believe that the universe began with the Big Bang, roughly 13.8 billion years ago. In the immediate aftermath, the cosmos was a seething hot soup of particles, energy, and radiation. It took hundreds of thousands of years for matter to cool and form the first atoms. Then, over millions of years, gravity began to draw this matter together to form the first stars and galaxies. Until recently, astronomers believed that the earliest large-scale structures, things like galaxies and clusters of galaxies, took time to evolve. The prevailing theory was that small building blocks of matter gradually came together over hundreds of millions or even billions of years, forming progressively larger systems. That's what made this new detection by the James Webb Telescope so surprising. This structure isn't just old, it appears to be massive, complex, and fully formed at a time when the universe should have been just a cosmic infant. The James Webb Telescope is uniquely suited for this kind of discovery. Its powerful infrared sensors allow it to look back through time by detecting light that has traveled across the cosmos for billions of years. Unlike visible light telescopes, which can be limited by dust or distance, Webb's instruments can peer through the veil of cosmic time to reveal what the early universe looked like. So, what exactly did Webb see? The telescope detected a vast web-like structure composed of ancient galaxies and clusters, all gravitationally bound together. This formation stretches across millions of light years and appears to have formed only a few 100 million years after the Big Bang. This means that somehow, vast amounts of matter were able to come together incredibly quickly to create a structure that rivals modern superclusters in scale. This raises fundamental questions. How did such a massive formation appear so early? Are our models of cosmic evolution incomplete? Is there some missing piece in our understanding of how gravity shaped the early universe? Some scientists believe that dark matter could play a role in explaining this rapid formation. Dark matter is the mysterious, invisible substance that makes up most of the universe's mass. Though we can't see it directly, its gravitational effects can shape the structure of the cosmos. If dark matter clumped together earlier than expected, it might have helped accelerate the formation of massive structures. Others suggest that our understanding of the expansion of the universe might need revision. Perhaps the early universe evolved more rapidly than current theories predict. Or maybe there were regions of higher density that acted as seeds for faster development. Whatever the explanation, this discovery forces astronomers to take a fresh look at some of their most cherished ideas. Adding to the mystery is the surprising level of organization seen in this ancient structure. It's not a random scattering of galaxies. Instead, it shows clear signs of cosmic architecture, filaments, nodes, and voids, all arranged in patterns that resemble the large-scale structure of the modern universe. In other words, it looks like a scaled-down version of what we see today. But it existed at a time when such complexity shouldn't have been possible. This discovery also has implications for the timeline of cosmic evolution. If large structures were already in place this early, it means that the first stars, galaxies, and black holes must have formed much earlier than we thought. That, in turn, affects everything from our understanding of how elements were formed to how light spread through the universe. In fact, the James Webb Telescope has already found galaxies that existed just 300 million years after the Big Bang. Some of these galaxies are surprisingly bright and massive, further challenging the idea that the early universe was a slow and gradual buildup of complexity. Instead, we may need to accept that the cosmos became organized and structured far more rapidly than we ever imagined. As scientists analyze the data from Webb's instruments, they're also discovering unexpected variations in the temperature and density of the cosmic background radiation. These variations may provide clues about the earliest fluctuations in matter that eventually led to galaxies and clusters. If these early fluctuations were more pronounced than previously thought, they might explain how large-scale structures could have formed so quickly. But perhaps the most exciting part of all this is that we're just scratching the surface. The James Webb Telescope is still in the early stages of its mission. As it continues to scan the skies, it may uncover even older, even more massive structures hidden in the fabric of space-time. Each new discovery forces us to rewrite the story of the universe and challenges our assumptions about how everything began. This isn't just about distant galaxies or ancient stars. It's about understanding our place in a much larger cosmic story. If these ancient structures formed faster and more efficiently than we thought, it could change how we view our own galaxy's origins. It might even influence how we search for life, since the early presence of large structures could mean that habitable environments formed earlier than expected. And while the James Webb Telescope is revealing new wonders, it's also raising profound questions. What other secrets lie hidden in the depths of space? Could there be even more ancient structures that challenge our understanding of time itself? Are we on the verge of a new scientific revolution that will force us to rethink not just when the universe formed, but how? These questions strike at the heart of cosmology. For decades, scientists have relied on the standard model of the universe, a well-tested framework that explains how everything evolved from the Big Bang to the present day. It's a model that has accurately predicted the behavior of stars, galaxies, and cosmic background radiation. But the James Webb Telescope is now challenging this foundation by revealing a universe that appears far more mature in its earliest epochs than our models can currently explain. If ancient cosmic structures like this one existed when the universe was only a few 100 million years old, it suggests either that the processes of galaxy and structure formation are more efficient than we understood, or that there were unknown mechanisms at play. One possibility is that the early universe underwent rapid phases of acceleration or clumping, perhaps influenced by unknown forms of matter or early cosmic inflation episodes. These ideas were once only theoretical, but Webb's observations are now providing real data that demand explanations. And it's not just a one-time discovery. Similar massive ancient structures are starting to appear in other regions of the sky as Webb expands its field of view. The more we look, the more we find. And this could be the beginning of a complete paradigm shift. What we once thought was rare or impossible may actually be common in the early universe. It's as if we've opened a window into a forgotten chapter of cosmic history, revealing events and formations that have been hidden from our view until now. The structure in question appears to be part of what astronomers call the cosmic web, a vast network of galaxies and dark matter that forms the backbone of the universe. Even today, the universe is shaped by these invisible filaments and nodes. They guide the distribution of galaxies and influence the movement of matter on the largest scales. But seeing such a network appear so soon after the Big Bang implies that the universe's skeleton was already forming almost immediately. This is like discovering a fully grown tree where we expected to find only seedlings. What's more, the James Webb Telescope doesn't just show the shape of these structures, it captures the light from individual galaxies within them. That means astronomers can analyze their composition, star formation rates, and even their chemical fingerprints. These ancient galaxies often contain elements like carbon and oxygen, which suggests that multiple generations of stars had already lived and died, enriching the cosmos far earlier than we anticipated. This raises another profound implication. If stars were already being born and dying this early in cosmic history, then the ingredients for planets, and potentially life, might have existed much earlier too. That opens up new timelines for the possibility of life elsewhere in the universe. It means that the cosmic conditions necessary for biology could have been present at a time when we thought the universe was still in its infancy. It's a humbling thought. We often view ourselves as living in a mature, evolved universe. But what if the seeds of complexity, structure, and even life were sown almost from the very beginning? What if we vastly underestimated the creative power of the early universe? Even as the James Webb Telescope brings clarity to these ancient epochs, it also deepens the mystery. Some of the galaxies within this newly detected structure appear to be unusually bright and large, defying expectations for such a young cosmic age. Others show signs of supermassive black holes at their centers, which shouldn't have had enough time to grow so massive. These observations hint at unknown processes or overlooked forces that may have shaped the early cosmos more dramatically than we realized. It's possible that these early galaxies merged rapidly, or that they formed from massive primordial gas clouds that collapsed faster than models predict. Another possibility is that dark matter behaved differently in the early universe, perhaps forming dense halos more efficiently, allowing galaxies and black holes to grow at accelerated rates. These are not just tweaks to existing theories. They could represent entirely new physics waiting to be uncovered. That's why astronomers and physicists around the world are now poring over the data, running new simulations, and proposing bold new models. Some are revisiting inflation theory, which describes the rapid expansion of the universe in its first fraction of a second. Others are looking into exotic dark matter models, or modifications to gravity itself. As wild as these ideas may seem, the observations demand explanation. Nature is revealing something unexpected, and science must respond. There's also a philosophical dimension to this discovery. The fact that something so vast, so ancient, and so intricate existed when the universe was just beginning forces us to reconsider our place in the grand scheme of things. It challenges the notion that complexity is a slow and gradual process. Instead, it suggests that the universe is capable of creating order and structure on unimaginable scales, almost immediately after its own birth. As the James Webb Telescope continues its mission, it's expected to uncover even more of these ancient structures. Each new observation has the potential to rewrite textbooks and reshape our understanding of the cosmos. We're witnessing the opening act of a new era in astronomy, one where long-held theories are tested against data of unprecedented clarity and depth. The telescope has already surpassed expectations, and it's only just begun. With its ability to peer across billions of years, it's showing us not just how the universe looked long ago, but how it became what it is today. These discoveries may even pave the way for the next generation of space telescopes and cosmic observatories, designed to go even further and see even deeper into the origins of everything. Ultimately, what the James Webb Telescope has revealed is not just a structure, it's a message from the ancient universe, telling us that the cosmos is more dynamic, more complex, and more mysterious than we ever imagined. A message that says, the story of everything didn't begin slowly and quietly, but with a burst of creativity that filled space with patterns and power, right from the start. And as we continue to listen to this message, one photon at a time, we may find that the universe still has many secrets to reveal, some that challenge our deepest assumptions, and others that inspire awe beyond anything we've yet dreamed. The cosmos is speaking. We just need to keep watching and keep asking questions as we travel further into the unknown.